Friends, welcome to my YouTube channel. Today we are going to discuss the basic concept of the uniformly distributing load for the cantilever beam. Before this video, shear force and bending moment, all the basic concept definitions already we discussed, and point load problems also I solved. So that previous video, all the basic concept will be there. So today what I am going to discuss here, how to find the shear force and bending moment diagram for the UDL uniformly distributing beam. So this side again I wrote the sign conventions for the shear force. Downward force will be positive if we'll take the right side, left side will be the upward force will be positive. And bending moment sign conventions, right side from if we'll take from the right side, clockwise will be negative and anti-clockwise will be the negative from the left side. And this bottom will be the reverse. Here also reverse will be there. So we'll consider only upper part. Now what is the variations of the line? Point load, if will be there, na shear force diagram will be straight line. Uniformly distributing line will be the inclined line. And UVL, uniformly varying load, will be the parabolic curve. Similarly, bending moment will be there, na point load inclined line, uniformly distributing load parabola, and uniformly varying load will be the third degree parabola. That will consider each and every problem. So now see here how to find the shear force and bending moment diagram for the uniformly distributing load for the cantilever beam. Cantilever beam means one end is fixed, other end will be the free. So if we'll see the shear force at point B, no load. At point B, particular points load not there, so shear force will be 0. Then in between no point load, only UDL, full beam we have uniformly distributing load. So directly we'll go the SA, shear force at SA. So what will be there? Suppose this beam length is L meter, So what will be the shear force at A? W into L. So W per unit length they given here. So W into L will be the shear force. So how we'll draw the diagram? First we'll draw the zero line. Zero line means shear force will be 0. So at point B, shear force will be 0. And UDL is there. So shear force for UDL, inclined line. See this shear force for UDL is inclined line. So we'll draw the inclined line from this point. So this height will be the WL. So this is the shear force diagram for this positive for this given UDL. This point is B. Now extend this line, we'll draw the bending moment diagram. So bending moment at point B, So load not with the bending moment at point B will be 0. Then what is the bending moment at point A? What will be there? So load, first we'll convert into load. What is W into L? It becomes load. Then UDL means we have to multiply the half length because UDL is rectangular load. Rectangular load means middle point will be the center of gravity distance, so I have to multiply. Or one more concept is there, suppose one line is there here, UDL. If we'll draw the load diagram for this, suppose this is W kilonewton per meter. And this is the length, L meter, UDL length. Suppose A and B point is there. If we'll draw the load diagram for this, point load will convert, load diagrams will draw here. So what will the load diagram will be here? That UDL means the entire weight will act at the middle point. Then what is the load here? W into L load. And what is the distance? L by 2. So this is the load diagram for the uniformly distributing load. So we convert it into point load. Now you see this, suppose we'll take the moment here. UDL moment I taken now. W into L load, and half distance. Half distance what is? Into L by 2. Half distance will be the L by 2. So that means rectangular load, rectangle means center of gravity point will be middle point. So once we'll take the UDL, this is the UDL concept, load into half distance. So this is our WL square by 2. What is this one? Suppose draw the zero line and this will be the negative. Because bending moment diagram we are taking from the right side. So right side clockwise directions will be negative. So this point taking moment about this, so this rotate clockwise. So this is negative. So this will be the bending moment diagram. So diagram will be parabola, because bending moment diagram for the UDL, what is parabola. So how we'll draw? So this will be the curved line. So this is the bending moment diagram for this UDL WL by 2. So this is the basic concept. So this way we can solve the question. So now I am going to take one question, then I will solve all those things. Okay. So just I write one question, then I will solve the question. So I will take the simple one UDL problem and we will solve now. So what is the given? A cantilever beam of length 2 meter. Question A. Cantilever beam of length 2 meter carries a UDL, uniformly distributing load of 1 kilonewton per meter. Run over, means from where they give, run over a length of 1.5 meter from the free end. So they given in the language. So we have to draw the diagram. So what is they're asking? Draw the shear force and bending moment diagram. This is the question. So now what I have to do now? We have to draw the diagram. What is diagram they given? First they given cantilever beam. So what will be the diagram? This cantilever will be one side fixed, other side free. So this, suppose we taken one beam, A, B, one beam will be there. This is the free end. Length will be, how much they given? Length is 2 meter. Length they given 2 meter. Now carries a UDL 1 kilometer per run over the length of 1.5 meter from the free end. So 1.5 meter, you take here this 2 meter. So 2 meter. Now 1.5 meter from free end. This is the UDL given. How much this one? 1 kilonewton per meter. So this is the given question. Now they are asking find the shear force and bending moment diagram. So now look how we will solve this. So sometimes diagram also they will give, sometimes questions will be there, you have to draw the diagram. So what is the run over a length of 1.5 meter from the free end. So 1.5 meter UDL will be there and no point load. Okay. So now we will find the shear force and bending moment diagram. So first calculation, shear force calculation. Shear force diagram calculation. So these are basic concept I wrote. So what I'll use, I will explain that why I will using this. So in the point B, shear force at B, no load. So shear force will be 0. In the point B, load not there. So it will be 0. Then this point you give A, B, this point you give C. So shear force at C. We have to find this load. So what is the load? 1 into 1.5. So 1.5 kilonewton. This is the shear force at point C, 1.5 kilonewton. Okay. Now shear force at point A. So in between no load. So same things will come 1.5 kilonewton because in between no load. So how to draw the diagram now? See, first we'll draw the zero line. Now sign conventions will write here itself. So this is the section. Already what I told, right side downward force positive and upward force from the left side will be the positive. This is the sign convention. This is the section. Okay, this is the section. Okay, little below draw this line, zero line. So we'll draw the shear force diagram. So this is the sign convention. So from right side, shear force at C positive, A positive, because downward force will be positive. So this force acting vertically downward. Now how to draw the shear force? So this point 0. So UDL means inclined line. Point load will be there point load, here shear force cap UDL will be inclined line. So up to there we have to draw the inclined line. What is this length, this distance? 1.5 meter, 1.5 kilonewton. Kilonewton, this is shear force at point C. Now C to A, no load, so will be the horizontal line. No load means horizontal line. This is the shear force diagram for the given question. So now this hatch lines you give, so this is the area for the shear force diagram. So this is the negative. So, okay, shear force diagram over. So this point is B, this point is A. Now we'll find the bending moment diagram. So bending moment diagram calculation. So what is bending moment at B? At B, because no right side force, so 0. Now we'll take the bending moment at C. So already you know moment is nothing but force into perpendicular distance. Force into perpendicular distance. So suppose we'll take the UDL. So what is the force? First we'll find out our load. 1 into 1.5 will be the load. So bending moment diagram, see the sign convention. If will clockwise will be there, right side will be negative. Now see bending moment I am taking here. See. So this is the rotations. Clockwise rotation. Clockwise rotation negative. So draw the 0 line first here. This point bending moment will be B point 0 at C. What will be there? 1 into minus 1 into 1.5 into 1.5 by 2. 1.5 by 2. Because once you are taking the moment, load into half distance. Load into half distance for the UDL. So 1 into 1. So how much these calculations will be there? 1 into 1.125 minus 1.125 kilonewton meter, because kilonewton is load, meter is length. So 1.25 kilonewton meter. Now we'll take the moment about A. So we'll see here bending moment at point A. Now look here. A point is fixed. Taking bending moment of A. Now load will be there up to 1.5 meters. So first what you like? Negative you take, because we are taking the from the right side. So clockwise rotations. This is clockwise rotations. So negative. Now 1 into 1.5. This is called load. This is called load. Then what is the half distance? Because we are taking moment about here. So 0.5. This distance how much? This distance will be 0.5. So into 0.5 plus 1.5 by 2. This is the moment for this. So see why I wrote this already. Once we did the support reactions, that things we discussed in the engineering mechanics also. So now look here. First load into distance. Moment formula what is? Load into distance. Load now 1 into total load 1.5 and half distance 1.5 by 2. But from the point A, where is this UDL? After 0.5 meter. So 0.5 meter we have to add. So if this will calculate, we'll get the bending moment at A. So what is the calculations here coming? 1.875. This is will calculate now 1.875 kilonewton meter. So this will be the will come. So now you see here UDL का bending moment diagram parabola. So parabola, now you draw a little second degree curve parabola. Now this no load here. Then what will be the inclined force will be there? Bending moment diagram what is? Point load, inclined line. So this will be the here. You can draw the inclined line. So this is 1.875. This is 1.125. This is the bending moment at C, this bending moment at B. So this is bending moment A we calculated. So this is the bending moment diagram for this given problem. So what we have to remember here, shear force diagram once will calculate UDL is there, inclined line, no load, horizontal line. Now see the bending moment for UDL, parabola, so I draw the parabola. Now point load or load not there, without load, this is called inclined line. So this way we can calculate the shear force and bending moment diagram for the UDL problem. So sometimes what they will give, 1-2 point load will be there, one side, this here also one point load, here also some point load, so that problems will go little long. So but this is the basic concept to understand the shear force and bending moment diagram for the cantilever beam. Okay, watch this video and subscribe the channels and share this video as possible as. Okay, friends, thank you.